Paleo students, Mr. Kaczynski with you. Going to do the 7.2 Practice Your Skills Solutions. This section is piecewise functions and absolute values. I'm actually doing it for a second time because I noticed some typos. So I corrected those, as you can see here in D. That will change our answer actually pretty dramatically. All right, so absolute value of -7 is 7. Absolute values are just a measure of how far something is from 0 on the number line. -7 is 7 units away from 0 on the number line. If you hit the math button on your graphing calculator or scientific calculator and you go over to the number list, there's ABS right there. That's absolute value. Some show it like this, where they give you the absolute value symbol. Some just say ABS parentheses, and you put whatever you want in the parentheses. All right, so there it is. The absolute value of -7 is 7. How far is 0.5 away from 0 on the number line? Well, it's 0.5 away. So in other words, absolute values are always positive because distances are always positive. Doesn't matter whether you're walking forward or backward, you're still walking a distance. So 0.5, the absolute value of that is 0.5. Now, on one like C, you actually need to do what's inside the grouping symbols, absolute value symbols in this case, first. So this is really saying what's the absolute value of -5, and that is 5. Some people make the mistake of doing the absolute value of 7 first, or of -7, and then they add it to 2. No, you do the addition, then you do the absolute value. All right, over here, these are called step functions. Those little symbols right there mean round down to the nearest integer. So the next integer to the left or below -7.2 is -8. And the next integer below 3.4 is 3. Then you add those up and you get -5. So that's called a step function. No, we didn't do it in the lesson, but it is in your book, and you've been encouraged in your book or to read the examples in your book as well. It's a small little addition. Hopefully you're catching that mistake now and learning from your mistake. I better actually see some mistakes on your papers, to be quite frank. Actually, I'd be surprised if you didn't have it as 7.2 plus 3.4 is 10.6. All right, now I'm telling you what mistakes to make. All right, this is the opposite of the absolute value of 5. So the absolute value of 5 is 5, and the opposite of that is -5. That is very similar to F. The absolute value of -5 is 5, but then we're taking the opposite of that, so we get -5 as well. Here's those step functions again on G. The next integer below -4.1 is actually -5. The next integer below 2.8 is 2, and then we multiply -5 times 2, and you get -10. That is not absolute value symbols. Very confusing that the book throws those in there at this. Not like there's not enough to learn in this section. That's okay. We'll slow down. We'll take our time. We'll do it right. And H, how about this one? Well, we've got the absolute value of -6, which is 6, being divided by the absolute value of 2, which is 2, and that is 3. We move on to number 2, and now we're solving absolute value equations and inequalities. So what number, when you take the absolute value of it, equals 10? Well, x could either be -10 because the absolute value of -10 is 10, or x could be +10 because the absolute value of +10 is 10. So there's actually 2 values that make this equation true. We're going to give both of them so that we can fully solve it. Likewise, on B, there's actually not 2 answers, but an infinite number of answers to this inequality. And what we do is say that x is greater than 4 or x is less than -4. I actually like those in the reverse order, to do the negative first, but whatever. You know, if I'm graphing those, we're saying that here's -4, here's 0, here's 4. We're saying that everything to the right of this point will solve that inequality, and anything to the left of this point will solve that inequality, but nothing in between. So numbers like, well, 0. The absolute value of 0 is 0, and that's not greater than 4. The absolute value of -5 is 5, and that's greater than 4. The absolute value of 4.1 is 4.1, and that's greater than 4. Moving on, this one. Again, there's two answers. X plus 1 could be equal to -8, or x plus 1 could be equal to +8. So what we have to do is solve both of these equations. You solve them the same way. Subtract 1 from both sides. Subtract 1 from both sides. And x could either be -9 or 7. -9 plus 1 is 8, and the absolute value of 8 is 8. 7 plus 1 is 8, and the absolute value of +8 is 8. So that quantity can either be -8 or +8. Same here. X minus 2 could be -4, because the absolute value of -4 is 4, or x minus 2 could be +4, because the absolute value of +4 is 4. Solve this equation. Solve this equation, and we get our two answers. So absolute value equations very often have two answers. Sometimes they have no answers. We'll see that in the reason and apply. -2 minus 2 is -4. The absolute value of -4 is 4. 6 minus 2 is 4. The absolute value of 4 is 4. All right, this one, a little bit different when we have the less than symbol as opposed to the greater than. X could be less than or equal to 2. And now it's an and situation. And it's got to be greater than -2. So it's got to be between those two numbers. So if we graph this, similar to how we did part B, we're saying that it could be this number, could be this number, and it can be anything in between is what we're saying. Okay, so numbers like -3 won't work. Absolute value of -3 is 3, and that is not less than or equal to 2. +4 won't work. The absolute value of 4 is 4, and that's not less than 2, but numbers in between will work, like -1. The absolute value of -1 is 1, and that is less than or equal to 2. So the numbers in between those work. Okay, so big difference between B and E there. One more. This one's kind of funky. X is greater than 0, or x is less than -0. That's the way we would put it, but that's just still 0. There's no such thing. And that's really weird because it looks like almost everything, but really it's more like this, that it's everything except 0. It can be greater than 0, less than 0. It just can't be 0. So let's even type that in. X can be anything except 0. All right, we move on to number 3, and we're just trying to say whether these are equal, less than, or greater than each other. So the absolute value of 5 is 5. The absolute value of 7 is 7. We're going to add those together, get 12. The absolute value of 5 plus 7 is like saying the absolute value of 12, which is 12. So we're going to go with equals on this one, equals. All right, what about over here? The absolute value of -5 is 5. The absolute value of 8 is 8. We're going to multiply those two to get 40. Over here, all we're going to do is take the absolute value of -40, which is 40. And again, those are equal to each other. We see those step functions, what we call them, reappear over here. So actually, right here on the left, we're going to actually do the subtraction first. -5.2 minus 4.5 is -9.7. Then we take the next integer below -9.7, which is -10. On the right, we're going to take the next integer below -5.2, which is -6. We're going to take the next integer below 4.5, which is 4. Then we're going to subtract them. These end up being equal to each other. Let me check my answers in the book, see if I'm doing well. Equals, equals, and equals. They're all equal so far. All right. On the left, we need to do the addition first. So we're going to do the absolute value of 9, which is 9. On the right, we're going to do the absolute values first. So absolute value of -2 is 2. Absolute value of 11 is 11. We're going to add those. And now, for the first time, we see that our answer is less than. 9 is less than 13. E is a pretty silly question to me. You got the same exact expression on both sides. I thought that was a typo, but it's not. I looked in your book. It appears the same exact way. I mean, it's the same exact expression on both sides. I'm not even going to bother simplifying them. And then F, absolute value of 4 is 4. Absolute value of this negative 2 is 2. So there we're doing 16. 4 squared is 16. Whereas on the right, I know we love negative exponents. We're actually going to simplify the inside first. Let's make that 1 over 4 squared. So we're doing the absolute value of 1 over 4 squared, which is like the absolute value of 1/16. Running out of room here, so I'll go like this, which is just 1/16. So that time we have greater than. Okay. Obviously this number is greater than 1 and this one's less than 1, so the blue is greater than the yellowish orange. One more, or a couple more actually. The absolute value of negative 2 is 2. The absolute value of 3 is 3. The absolute value of negative 5 is 5. We're going to add all these and get 10. Whereas on the right, we're going to add them first. Negative 2 and negative 5 makes negative 7, plus the 3 makes negative 4. Then we'll take the absolute value, and we end up getting that the left side is greater than the right side. Last one of these anyway. What do we got? We got the absolute value of negative 2, which is 2, times the absolute value of 6, which is 6, divided by the absolute value of negative 4, which is 4. So we have 12 over 4, which is 3. And on the left, we've got the absolute value of negative 2 times 6, which is the absolute value of negative 12, over the absolute value of negative 4, which is 4. We should simplify that top more. Absolute value of negative 12 is 12. And 12 divided by 4 is 3. These are equal to each other. Feel free to rewind, pause, ask questions. If I'm going too fast, ask questions in the Microsoft Teams chat, or you can put them in the comments on YouTube if you have access to them. All right, evaluating functions. F of 5. All right, f of 5. Here's the function for f of x, 3x minus 5. So we're going to do 3 times the input, 5 minus 5, which is 15, minus 5, which is 10. This is usually the way I show my work, just lining up the equal signs. I don't bother rewriting the f of 5 every time, but I can clearly see that my input was 5 and my output is 10. That's function notation. All right, how about f of negative 2.5? All right, we're going to use the same function. 3, instead of times x, we're going to do times negative 2.5 minus 5. 3 times negative 2.5 is negative 7.5. And when we subtract 5 from that, we get negative 12.5. Then our functions get switched up here. And now we're being asked about g. Okay, g of x is the absolute value of x minus 3. So we're going to do the absolute value of negative 5 minus 3. We just saw how order of operations works on this. We're going to do the subtraction first in this case because it's inside the grouping symbols. Then we'll take the absolute value and we get g of negative 5 equals 8. One more, g of 1. That's the absolute value of 1 minus 3. The absolute value of 1 minus 3 can be rewritten as the absolute value of negative 2, which is 2. And then number 5, plot the function y equals the absolute value of x. Sometimes it shows up like this on a lot of calculators, probably the ones you borrowed from me in yellow. Use the trace function to evaluate these two things. Okay, let's go do it. Let's go to y equals. We'll do math, number, absolute value of x, and we graph it and get this cool V shape. We'll use the trace function and scroll over or just type in 2.8. And obviously the absolute value of 2.8 is 2.8. So let's write that down. The absolute value of 2.8 equals 2.8. We should probably also, real quick, note that the absolute value of negative 2.8 is 2.8. That's how we get that symmetry in the graph. And what about the absolute value of negative 1.5? We know that's going to be positive 1.5, but let's type it in. There it is. Negative 1.5 gives us 1.5, just like positive 1.5 gives us 1.5. So there we go. All done. Like I said, encourage your questions, your confusions, your misconceptions to share them with me and your classmates. Love it. All right. Have a good one, and I'll